Welcome folks to our lesson 5 is an extension of lesson 4 where we are still doing how do you connect circuits in electricity. Okay? Now, before I go to this circuit and explain, I want us to know in the cell that you are given, the source of PD, the cells can be in series or in parallel. Okay? And now it will depend on the cell holders that your school has. There is this kind of cell holder. You can see it. You can see one side has mabati. It has spring, and then there is another side which has a pointer. Okay? There is no mabati on this side. So the mabati here, this metal plate, is to help you connect the positive and the negative so that you don't have a continuous type. We have two types here. Okay? Okay? You have this is a continuous, you can see one after the other. Okay? One after the other. You can see negative, positive, negative, positive. So these two here are connected using the metal plate inside. Connected, okay, using the metal plate. That's why you are able now to have them turned. Okay. So schools may have this or may have single cell holders. This is double cell holders, and even there is triple cell holder. Now you have to be familiar with what you have in your lab. For us, we have this, and also we have this type. So for my experiment, I want to show you, suppose you have the two single cell holder, okay, and you are told to connect in parallel. So in parallel, it is negative and negative. You can see negative and negative, and then positive and positive. Okay? So what happens? You take a wire, you take some wires, and then connect. Okay? I take a wire and connect here. This is positive, positive, negative, negative. So I have to connect these two terminals and again these two terminals. So I'll use two different colors. Again, I want to hold. You can see negative, negative, and then positive, positive. So I can connect this to that. And then I can also connect this to that. Okay? After doing that now, positive to positive and then negative to negative, after doing that, some of you are very clever. You remove this seal and then you connect. Then you remove this seal here, then you can connect. So you have this here, then from here you can do your connection. The same thing here, this green one, from here you do connection. That's okay. Okay. Alternatively, you can have another cable. You can have another cable. You can have another cable, connect, and then the two come together. Then I have another one here. This. So I have this from one negative and this from another negative. So my connection will start from here. This now. Then we have this also, the two from there. Okay? So that is how you connect parallel cells. Remember, positive and positive, negative and negative. Okay, good. Now, for me, I want to connect a circuit shown on the board. The circuit shown on the board. Dark tunnel. The circuit shown on the board, this. The first thing, arrange items the way they are. So I have the cells, the two cells. I have them here. Okay, I have them here. Correct. The two cells, I'll put them there. Then I have the switch. I will show you in a short while the arrangement, the switch. And then what else do I have? I have next, from the farthest line, next I have the voltmeter. So I take my voltmeter there. Then next I have the ammeter. Take it to the left. Okay, the left. And then I have mounted wire here. So I focus down, you see. Look at that. That is my switch. That is my switch. It is on the same line with the cells there. Okay? Then what else? From the farthest line, the next is voltmeter. You can see it. I'm doing it so that the camera can focus. Then next, after the voltmeter, on the left, I have ammeter. You can see. Then I have the mounted wire. Okay. Now, I want to take you back to the diagram. I am trying to focus on loops. How do you tell loops? If you look at this diagram, I have this connection here, there. That would be a loop in my context. Okay? That is a loop. This is a loop. Okay? Another loop is here. So there are two loops. Mizunguko miwili. Okay? Mizunguko miwili. Two loops. So what happens? If you go by my approach, connect the terminals of voltmeter and leave it out. So let me connect the terminals of voltmeter. Okay, there. I take the voltmeter, connect, then connect. So I've connected the terminals of voltmeter. Okay, you can see. Then leave it out. Leave it. Put it aside. Put it aside. Okay, I'll put it aside. So what is remaining, you can see, is a loop. Now, look, I've taken the voltmeter away. So what is remaining is this. You can come, go back. Next is to connect now the circuit. I need a wire, first of all, to make for me a small connection on my source. Remember, this source, it cannot hook. And do you know why? Let me focus. You know why? It cannot hook because this company is different from this. They are different. So even if I try to hook them there, you can see this should be able to get in. But since they are not from the same company, you cannot hook. It is difficult. You can't. I've tried, it can't. So what happens? I just take a cable. I take a wire here, connect with this. That. So instead of crying they cannot hook, I've just done that. Then take them back. Take them back. There. Okay? There. So you connect from one point and then go round. So let us get my point from positive. According to the diagram, is from positive. So I connect there, positive. I go to the switch. Then from the switch, I connect to the ammeter. Okay? Then from the ammeter, it goes to the mounted wire. There, the mounted wire. Then mounted wire, there is a crocodile clip. The wire with crocodile clip takes you back. We can have one here, yes, here, from somewhere, some points on the mounted wire. From some points on the mounted wire, I'm going back to the source. Now that simplifies your work. Then you will bring in later the voltmeter. But so far, if you put in the switch, the current should be able to flow. When I put on the switch, the current should be able to flow. If I find it is too, the deflection is small, I change the scale. Then you see, okay, you can change the scale when the deflection is small. I hope you are seeing there. Let me bring the camera. Hope you are seeing here. Okay, let me see. So the circuit I've connected. Now I'm testing, because this can give me pointer below 0, or pointer within the scale, or pointer outside. So if I put that, you can see now that is okay. So I remove my key, because I know this circuit so far is okay. Okay, now I try and bring in the voltmeter. Okay, the voltmeter. We go back. The voltmeter connects this side. It connects any point on this, and maybe I can put it next to the ammeter. So I bring the voltmeter. We go down. The voltmeter was here. So I'm trying to put this to face the camera so that you can get. I just connect there, and another one I connect it here, and then I see what is happening. Okay, now depending on the question, you may find that there is no deflection because of resistance. But let us put on now the switch, and we see there. I want you to see, after putting on the key, this is the voltmeter. I think it is focused. Look at that. Now I told you, you don't need to cram. You don't need to cram. This, if you remember, is corrected by this. Okay, let us try. I want it, when the camera is focusing, I remove this and I remove that. So this one, which was on black, now goes to red, and the one which was on red comes to black. Look, if I find this is not moving, I can test with this another scale, smaller scale, if deflection is small. See, big. Okay, so I take back the camera. Everything is working. When everything is working, I remove the key. Okay, so after removing the key, I now prepare. What do they want? They want what was the current when the switch was closed, and the PD. Those ones you can get. Okay, those ones you can get. Now they want when the length is 100, you read the PD, and you will subtract from EMF. Okay, so suppose, just for demonstration, because this will be varying, this is getting the potential drop along this resistor, along this wire. So suppose we make it shorter. You will go according to the question. If they say 20, you put at 20. If they say 30, you put at 30, and so on up to 100, depending on the question. But let us see, for example, I've changed from where it was, and we see, look at that. See, look at that. It has changed. This one has changed, this one has changed. I don't want to be behind the other. There. Can you see this? Can you see that? Maybe again, another one. You have been told. See the variation, see the variation. I want to go again, maybe more. Look at that. It is somewhere there. These ones are changing. Okay? Are we get there? So that is now terminal. Terminal PD. Okay? Terminal PD. This is terminal PD. Okay? So as I finish, what is the EMF? What is the EMF? The EMF is that. That is the EMF. Okay? I want you to get the difference. This is an open circuit. Not in the sense it is not complete. There is no load that consumes the current. Okay? So this is what we call EMF. You can see the way I've connected. Maybe I even reduce some wires. There. Can you see? I want you to get it right. Let me move it somewhere here. And then this. So the voltmeter is just measuring what energy is contained here. Okay? That is EMF. And it is the PD, the potential across the source on an open circuit. What is open circuit? An open circuit has no load which consumes the current. There is nothing. There is no any other device. This one is to give us what is here. This is showing us what is contained here. So what we have here, when there is no load, when it is an open circuit, is known as EMF. But when we are carrying out the experiment and we are using a meter which shows us there is current flow, then the PD across the load is terminal PD. Okay? So those are things you should be able to get. The moment you go to the lab, you take the voltmeter across the source, you are dealing with EMF. When you do some connection such that current start flowing, whatever voltmeter shows is terminal PD. Keep on subscribing, folks. You will get more. Thank you. Bye-bye.